So we use the next 10 minutes for review of yesterday's discussion. If there's something somebody wants further explanation, you can kindly bring it to my attention. Anything that bothers your for which you want further explanation, yeah. I think one area which most people wanted better and further explanation, if I remember, was about the penile growth, the growth of the penis. And I tried as much as I could to explain that all of us know that the reproductive system only begins to function during puberty. So the structures, all the structures will be there, and they must be there from birth. All right, but they begin to function. So you know that from as far as the male reproductive system is concerned, its main function is to produce sperms and also to produce androgens. In this way, testosterone. All right, but it will be dormant until puberty. And you said that puberty these days may start as early as 9 years. When it comes to females, some of them even start puberty from age 8. Now, we say that from 9 years, 10 years, thereabout in males, puberty will start. And as to how it starts, that is by nature. All we know is that all of a sudden, the hypothalamus, which is located in the brain, begins to produce what we call gonadotropin releasing hormones. I'm sure all of us from the basic anatomy we know, you know the HPG axis. Who has an idea about the HPG axis?
I'll go.
The HPG axis. Can anybody tell us something about it? It's important in all anatomy, whether it is even at diploma level, you will be taught about the HPG axis. And this is how most of the hormones are controlled. So the H stands for the hypothalamus, P, the pituitary, and then the G, the gonads. So the gonads, once it comes to the male, we are talking about the testes. Once it goes to the females, we are talking about the ovary. All right. So the HPG, the hypothalamus will trigger the release of gonadotropin releasing hormones during puberty. And that's why I'm saying that is by nature. As to how it starts, I don't know. But all of a sudden, the body begins to appreciate the fact that it is of age and begins to produce the gonadotropin releasing hormones from the hypothalamus. And that will hit on the pituitary. Okay. So the pituitary will now produce the gonadotropins, the gonadotropins are two hormones, the LH, luteinizing hormones, and then the follicle stimulating hormones. Okay, so they are gonadotropic. It means that they also work on the gonads. So they will go, if it's the male, they will go to the testes. And then so the LH and then the FSH will now work. We'll come to that. We'll come to the details of how the FSH and then the LH combine to produce testosterone. At this time, the testosterone which is produced will be sent to the bloodstream, even though they are produced in the testes, but they will be sent to the bloodstream to now hit organs which must develop at that age. And some of the organs, basically, if it's a male, we are going to talk about your penis. And we're also going to talk when it comes to testicles. The testicles, because the testicles are now being gingered to produce hormones. Now, at this point, the testis is now producing the androgens, which is the testosterone. So it's like now they are being activated. So the testicles will also begin to become big. And then, of course, the penis will also be big, will begin to grow. Other areas, that's where the voice breaking and other aspects which you consider as secondary sex characteristics. They will all begin to, and they will begin to function under the influence of the testosterone. So you see that within that period of puberty, what is going to happen, and all the major work of the testes will be to produce testosterone. And all the testosterone at that time will be concentrated on then also developing the male sex characteristics, secondary sex characteristics. I hope you are getting that point, which will include the penis. So the penis will now, even though from birth up to puberty, there will be minimal growth, very, very minimal, insignificant. But all of a sudden, during the puberty, you see that the penis, so if you have a boy, a small boy, and a son or this, and then you begin to say, your penis is becoming big, you are now becoming a man. Okay, so that will tell you the man that your boy is in the started puberty. All right, and then of course, that must now begin to also explain certain things about the fact that if he jokes and have sex with any girl, the girl can be pregnant. All right. So that is what I know. Then, hello, can somebody put your listen off, your mic off, please? So that is what will happen. And so within that period, the penis will begin to grow. All right. At the end, please, the mic on is disturbing, please. Now, at the end of the puberty, testosterone will now be concentrated in developing sperms. So the level of testosterone that is expected to be in the serum or in the blood will reduce to about 1/100th, to reduce drastically. Now, all the testosterone that is produced by the testes will be used within the testes to develop or to produce sperm. That is what it is. So there won't be enough testosterone in the serum for further growth of the penis. The small amount of testosterone will be just to also provide some other things and like producing your libido and so forth and so on. Okay, and you know that the testosterone can also be used endogenously to produce the dihydroxy testosterone, which is also useful for some other things. So that is the little that I know. So yesterday, I think the emphasis was that after puberty, that's when puberty is individualistic. That it can start early in some people and end early, or start late in some people and also end late. But by and large, usually around 21 years. If around 21 years your penis is still small, then it's a different thing, which we'll talk about later. But after 21, it is assumed that most adolescents will have completed puberty. All right. and therefore you don't expect any further increase in the size and length of your penis. Okay, that is what I want us to establish. Testosterone, which is needed for the growth, will have reduced drastically, and therefore further growth of the penis is very unlikely. I use the word unlikely. I'm not saying it is not possible. It is very, very unlikely. All right. So that is what I remember, that probably some of you still wanted more explanation. And that is what I can add. Virtually the same thing I'm trying to repeat. All right. So is there any other thing somebody wants us to talk about? Otherwise, we're starting today's program. Today, we're just going to continue from where we left off yesterday. Yesterday, we were done with a lot of the things about the penis, but we are now going to go into the structure of the penis. What we talked about was the physical characteristics. All right. Now we're going to talk about the structure of the penis, because you need to appreciate the structure of the penis to be able to also understand the element of erection. You also need to understand erection very well, because these days there are a lot of issues about erection, that is erectile dysfunction. So if you understand the tissue structure of the penis, and you understand how it works to produce an erection, and then if there's a problem of erection, which is erectile dysfunction, then you know where to tackle. That is the concept of this discussion. So we need to get some little more information about the tissue structure of the penis. So structurally, it has erectile tissues, because of the way the penis, because it will have to erect, it means that it must have the capacity to expand. And whichever tissue can expand, it means that there must be erectile tissues. Okay, so there are three major erectile tissues. We have two corpora cavernosus. So because of the fact that corpora cavernosa is two, which is plural, we have it as corpora cavernosa. If you are talking about one, it's corpus cavernosum. Okay, so as soon as you talk about corpora cavernosa, you are talking about the fact that you are dealing with two things. All right. So as we move along, you also come across things that are paired and things that are singular. And once we come across any of those things, I'll let you know. All right. So the corpora cavernosa, we're talking about the fact that it's paired. If you want to talk about one of it, becomes corpus cavernosum. And then there's also a third one, because we are saying there are three erectile tissues. So if there are two of the corpora cavernosa, then there must be another one. That's also another corpus. And then it is corpus spongiosum. Okay. So you see that whether it is cavernosa or spongiosum, they are all corpus. That's why remember that when you're talking about the divisions or segments of the penis, you said that the body can also be called corpus, because the body is primarily made up of the erectile tissues, which is corpora cavernosum, two of them of the corpora cavernosum, and then also one of the corpus spongiosum. How that point is established. There you will see a picture where you see the corpora cavernosa run side by side. Okay, and are contained within a bilayered. When I say bilayer, it means that's a double layer. A collagenous sheet called the tunica abyginia. This tunica abyginia is very, very important. I mean, it will reflect in other structures. Okay, so remember about the tunica abyginia. Right? So that's also an elastic tissue, which is also covering the corpora cavernosum. All right. So within the corpora cavernosum or within the rectal tissues, there are variously sized sinusoids. You know, sinusoids. Sinusoids are specialized blood supplies. Okay. So the variously sized means that the size is not uniform. Some can be large, some can be small. You talk about where the sizes which are large are concentrated, and areas where the sizes may be small or may be varied. All right, as we move along, you know all those. So within the tissue, the penile tissue, you have the sinusoids, which are supplied by blood vessels, and of course, collagen. Remember, we said that the collagen is where we are also talking about the tunica aborigine, which is also a tissue, elastic tissue covering the corpora cavernosa. Right. So this is a picture of it. Right. Let me see if I can get back my pointer. All right. So this is, of course, a flaccid or urinary or pendulous penis. All right. Now you are going to see how the tissues are structured. Now, if you look at the right side, all right, so you have your penis here. Now, from here, you see that now I think it is better seen here. See, there is this tissue, one of it, and then one on the, sorry, one by the side of each. You see, when you look over here, you will see that this is one tissue. That's one erectile tissue. And then two of the same type. And so, of course, this is going to be the corpus or the corpora cavernosa, because we say that corpora cavernosa are two, and they are the same. So you are seeing them lying side by side of the corpus spongiosum. I hope you are getting it. Try and follow me. Right. So inside the penis and running the length of the penis are three cylindrical erectile tissues. The two large ones, which is the corpora cavernosa, which are this and that, and then the corpus spongiosum, which is the middle one. All right. And then within the middle one, when you come here, within the middle, you have your urethra. So it means the urethra traverses the corpus spongiosum. All right, try and follow it, and you appreciate it very well. So if you're talking about spongiosum, it is that one which encloses or which houses the urethra. Okay, and then by the sides, you have the corpus cavernosa. All right. I hope that you've also followed this aspect. All right. So this is the cross section of the penis shaft. When you talk about the shaft, you're talking about the body. So from the shaft, this is the corpora cavernosa. Oh, okay. So you saw that there were two, and they lie side by side. All right. So when you look at the cross section of the penis shaft, the two like corpora cavernosa lie together on the upper part of the shaft, while below lies the corpus spongiosum, with the urethra running through its middle. So this explains this cross-section area of the penis. All right. So it is the same thing here. So this corpora cavernosa or corpus cavernosum, once become corpora cavernosa. And this is one, which is the corpus spongiosum. And within the corpus spongiosum, this hole here is the urethra. And of course, you have the sinusoids. You see the sinusoids and blood vessels, collagen all around the places. All right. So you need to appreciate this structure very, very well. All right. So coming here, another explanation to what you said, the corpus spongiosum, which is the middle one, is ventrally located. That's within the middle. All right. And encloses the urethra. Of course, the urethra is not shown here, but I'm saying that the urethra, you know that the urethra runs within or traverses the spongiosum and opens at the tip of the glans or the tip of the head. All right, here. All right. So you see that at the head, there are no corpora cavernosum. Look very, very well here. So at the head, okay, there is no corpus cavernosa. It is just the corpus spongiosum, which expands at the head area or the glans area. And we said that the tunica, that is the collagen fiber, the elastic tissue, covers the corpora cavernosa. It covers this ones. So that it means that there's no covering of that elastic tissue here. So take note of that. So you see that when it comes to erection, this side is stiff. The shaft is stiff, but this side is not as strong or stiff as we have it here. That's by nature, because this side is going to penetrate into the vagina. So if it's as stiff as this side, then it means that there's going to be a problem, for especially for those of you who may have a big dick. If it's big, and this side, the glans, which is going to penetrate, is as strong, stiff as this side, then there's going to be a problem for penetration. The woman is going to actually suffer. So you see that as we move into erection, the corpus cavernosa has an elastic tissue covering it. Okay, which is the tunica albuginea. It is covering it. It's also elastic, so that it gives it an extra strong what do you call it, hardening. But it is not here. Okay, it is not here. It is not here because the nature, by nature, they don't want this side to be as stiff as this side, so that this gives a little, even though it is erect, this side is still comfortable and then can penetrate, so that the shaft itself, the body itself, will not be stiff and do the thrusting. I hope that point is also well noted, because as we move along, you appreciate the fact that the presence of the albuginea gives the shaft an extra energy to maintain erection, but it is absent here. All right. Once it is absent here, then it means that it is not going to be as stiff as you have it here. That's all I'm talking about. Okay, right. So the second point here is that the tunica albuginea, which is that elastic collagen, which is enveloping the cavernosa, is less dense in the corpus spongiosum and also not present in the glans. So we are saying that the tunica albuginea covers the cavernosa. It doesn't cover this. Over here, it covers it, but it covers it very less. Because over here too, you see that within it lies the urethra. So if you put more pressure on the urethra, then there's going to be constriction. The urethra will not have space to even breathe. Okay, so over here, within this part, there's less of the tunica albuginea, but in the glans, they are completely absent. So that is also something that you need to appreciate. The sinusoids of the corpus spongiosum are larger than that of the corpora cavernosa, and this one too should be understandable. You see, we say that during erection, once we get to the phenomenon of erection, you see that erection is just engorgement of the penis structure, or the penis, the penile tissues, and blood is just entrapped. Okay, now and the blood flows through the sinusoids, and we're saying that So the flow of blood into it will cause an erection. But we see that the spongiosum have no erectile tissue covering it. Okay, they don't have erectile tissue covering it. So it means that if the sinusoids there are not large enough, then erection can be compromised. So that's the reason why the sinusoids, that is the source of blood supply within the corpus spongiosum, are larger. Okay, they are not as large as those within the corpora cavernosum. That is, so you understand all this so that once it comes to erection, you appreciate it very, very well. So engorgement of the corpus spongiosum constricts and pressurizes the urethral lumen to allow for forceful ejaculation. So we are saying that once blood gets into the sinusoids, of course, they'll become larger. As they enlarge, they put pressure on the adjoining tissues. Okay, so it is that concept that will now force, during ejaculation, that will now force semen to flow out. But it doesn't play a major role in the erection. Okay, once it comes to the erection phenomenon, I think more things will come up and you appreciate it better. Let's also now seal the penis. Blood supply. You appreciate that blood is supplied to organs through the arteries. Okay, so arteries will supply blood to the organs, and then veins will also take blood, will drain blood from the organs. This one we know from basic anatomy. All right, so blood is coming through a lot of arteries, and then the final small branches of the arteries that will supply the penis are called the helicin arteries. So they supply the sinusoids, and so that the sinusoids are blood vessels within they are the blood vessels within the penis architecture. All right, so the helicin arteries will do the supply. Okay, so the arteries are supplying the blood. So veins must also take the blood away from the penis, and those veins are called emissary veins. Okay, so we have the helicin arteries supplying blood to the sinusoids, and then the emissary veins also taking blood away also through the sinusoids. And then, so that is venous drainage, and then the arterial supply. So if the rate of supply exceeds the rate of drainage, then it means that there's going to be an entrapment. Okay, and like I've said, you need to appreciate all these things so that once it comes to erection, explaining the physiology of the erection, you appreciate it. So you are saying that the arteries or helicin arteries will supply the blood to the penis. Now the emissary veins should also drain it. Okay, so at any particular point in time, the rate of supply should be equal to the rate of drainage. However, something will happen to the extent that the supply will be increased, and then the drainage will be reduced. So as soon as that happens, it entraps blood within the penis. That is the blood engorgement, which we call blood engorgement, and that is what also initiates erection. Okay. So in the flaccid state, the helicin arteries are tortuous and constricted. In the rest state, they are straight and dilated. This should also be understood. All right. So once they are flaccid, it means the flow of blood is very, very slow. The flow of blood to the penis is slow. It should not be also absent, because once it's absent, it means that the penis will die, because it needs to be nourished. All right, the penis should be nourished. So if there's no blood supply at all, of course it will die. I mean, now, so there's that normal flow of blood during the flaccid state. Okay, so once now at a point, once the blood flow becomes it's like when you have a tube, let's say, yes, any tube there, and blood flow to blood is flowing through very lightly. The tube may be tortuous. It's like may not be straight. As soon as you have blood flowing through it, you see that all the wrinkles and then the turns on the tube will now also straighten up. This is what we're saying. So the flashes, the arteries will be tortuous and constricted. Once they are erected, then they'll be straight and dilated to allow more blood to flow through it and therefore to maintain erection. So nerve supply. The penis has both somatic and autonomic. I want to talk about the autonomic. You're talking about the sympathetic and parasympathetic nerves. And talk about the somatic, somatic nervous system. You know this from basic anatomy. Somatic nervous system and then the autonomic nervous system. All right. So the penis has all these supplies. But their supply is technically around the S2 and S4 spinal cord. All right. Hello. Can you put off your listing for us, please? So you appreciate that the nerves are coming from the S2 and S4. Now you know that the spinal cord, you have the L's, the S segment, the T segment, and then this one too is for different distance. But within the S2 and S4, this is where a lot of the nerves start from, the nerves that are supplying the penis. That's where they are starting from. That's why somebody will tell you that, oh, if you have a spinal injury, you are likely to have erectile dysfunction. You see, the spinal injury, because a lot of the nerves that control erection are coming from the spinal cord within the S2 and then the S4 section. So what it also means is that if the spinal injury is at other places, let's say the L section or the T section somewhere, it's unlikely also to affect your erection. So that's what it means. Because the innervation, the nerve supply for the penis is within the S2 to S4. So it means that if you have an injury within that space, it is automatically going to affect your erectile function capacity. Okay, right. We have also said again that the glands, the corona, the penis can contain numerous free nerve endings. So nerves are also very important during erection. So we said that the tissue structure itself has important role to play in erection. The blood supply itself also has a role to play in erection, and then the nerves also have. So erection is an interplay of innervation, nervous system, and now of course also the tissue structure. So you need to have a very good understanding of all this, so that once they come to the phenomenon of erection, you appreciate it better, and therefore you can also connect it to erectile dysfunction. All right. We will deal with all these things in detail, but I'm just mentioning them here so that once you get there, you can always link up. All right. And this way, yesterday we talked about the glands and the corona, and then we said that this is where some people think that, oh, if you have circumcision, they are likely to affect your erectile capacity, just because we said that the foreskin is attached to the corona, okay, under the corona, which is the pherino. All right, so during the removal, you are likely to destroy a lot of the nerve endings. And so once you destroy a lot of nerve endings, you are likely to compromise on your sexual stimulation. That is that. But a lot of literature has also disproved that yes, after all, the amount of nerve endings are so much, so that the amount which will also be destroyed is not enough to compromise the rest. I mean, something like that. So all that it means is that if you have a circumcised person and then uncircumcised person, they all can have the same sexual stimulation capacities. That's what they are saying. All right. So still on the nerves. You know, the nerves, when it comes to the autonomic nervous system, you are talking about the sympathetic and the parasympathetic nervous systems. Now, all of us know that the sympathetic is usually for what people call the what do you call it? A way to remember this free and flight, something like that. It's like it gives you capacity to move fast. Okay, so sympathetic nervous system is for hyperactivity. Let me put it that way. Parasympathetic nervous systems rather slows down things. Okay, now you need this to also appreciate the concept of erection. You deal with erection because I'm saying that when we are dealing with the male reproductive system now, one of the major problems is erectile dysfunction, which people call impotence. But you know that people also misinterpret impotence to mean infertility. Infertility is a different thing altogether. Impotence is what is described as erectile dysfunction. Okay. Now, so your sympathetic nervous system will rather cause the veins, so or the penis to get to the flaccid state, the sympathetic, because sympathetic gives how do I call it? Causes the body to be in hyperactivity of a sort, and it contracts the muscles. So once the muscles are contracted, what happens is that it constricts the arteries. Okay, because we are saying that erection, once we get there, erection is more about blood flow, allowing more blood to flow. If the blood has to flow, the arteries must be open because they are the source of the supply. All right. So once you get the sympathetic nerve contracting the muscles, once they contract, they cause the arteries to rather close up. Okay. Rather, you need the arteries to open up. So once they close up, what happens is that the rate of flow of blood to the penis will be minimal. And once flow of blood to the penis is minimal, it means that it cannot erect. All right, it cannot erect. So once we are going to explain erection in full, I just want you to know that sympathetic nervous system is against erection. You see, your sympathetic nervous system is against erection. However, parasympathetic nervous system, which responsible for muscle relaxation. If the muscles are relaxed, then what it means that the arteries, once they are relaxed, they open up. When they open up, it means that they can now allow more blood to flow through. So parasympathetic nervous system, we say they are pro-erectogenic. Erection, I mean, anything that will cause the penis to erect, we say it is erectogenic. Pro means for. Okay. Then the sympathetic will be anti-erectogenic because it is against erection. And that will mean that once your sympathetic nervous system is activated, your penis will not rise. You understand? You see, once it comes to erection, once we are doing erection, more of these things will come up. You see? So parasympathetic nervous system is pro-erectogenic. That is, it is that which will cause the penis to erect because it causes the muscles to relax. If the muscles relax, what happens is that they open up, the arteries will now open up. Once the arteries open up, they allow more blood to flow into the penis. And we said that basically erection is about more blood rushing into the penis, and then less amount of the blood taken off from the penis. That will cause the erection. Okay, so that is what it is. And we will talk about what we call nocturnal penile tumensis, when in the night, once you sleep, there is erection. Because in the night, we will deal with those things, but in the night, we have the sympathetic deactivation, because in the night, there's the element of you being hyperactivated is minimal. Okay, it is the sympathetic nervous system which will cause you to be hyperactivated. That's why we say it is for free and flight. That is like you can run at any particular point in time. But in the night, that nervous activity will have to be deactivated, and to promote the parasympathetic nerve, which will now cause the muscles to relax so that you can sleep. Okay, so, and you know that parasympathetic nervous activity is pro-erectogenic. Okay, it's pro-erectogenic. So once now your sympathetic nervous system is deactivated in the night, and then rather the parasympathetic nervous system, which is now activated, that shift will cause the penis to erect automatically, without whether it has nothing to do with whether you are sleeping with a woman or you are dreaming about a woman. No, but that shift of sympathetic activation to parasympathetic activity, which one of which is against erection and the other one is for erection, will cause your penis to erect at night. That is the simple explanation behind sleep-related erections. And you deal with all those aspects in full. But what I'm saying is that the penis has sympathetic nervous system and then a parasympathetic nervous system, all of which originate from the S2 to S4 segment of the spinal cord. Right. So that is good, at least for this course. That is what we have for the penis. But there's what we call some semblance of the penis and the clitoris. We are dealing basically with the male, but of course, we want to have this analogy with the clitoris. So you call it the homology of the clitoris. That homology is like commonalities. All right, so the penile structure, how it also shows up in women to some extent. So the penis and clitoris, of course, found in women are considered homologous structures, as they develop from the same embryonic tissues and share common developmental pathways. All right. The penis is homologous to the clitoris with other related structures like the scrotum, foreskin, various glands, also having homologous counterparts in females. So all the things that we talk about the penis, if they take the clitoris as a structure, you see that they have a lot of semblances. So the penile and clitoral homologies, the glands, all of us know of the glands, which is the head of the penis. Okay. It has its counterpart also in the females, the clitoris. So remember we said that the glans is highly innervated. All right. And then that's where it provides a source for sexual stimulation or for sexual arousal. So that's how all of us know that the penis, the clitoris in women, is also erectogenic. I mean, you can cause it to erect. The woman can tell you that the clitoris can erect. Okay. And if it can be erect, it means that it must be stimulated. It must be stimulated. Then the head, the glans, is the source of the stimulation. All right. So but that doesn't mean that you have to go and squeeze in somebody's clitoris. So the glans or the penis is highly innervated, and if you want to stimulate any sexual stimulation, You concentrate on the glands, and of course, even the corona, more than the body of the penis. All right. Same way, the clitoris, the tip of the clitoris is also called a glans, and then also provides the same sexual stimulation. So we also have corpora cavernosa and the corpus spongiosum. All right. These are the erectile tissues in the distance. They have similar distance within the clitoris. And remember, these are the places where blood will have to flow to cause an erection. All right. So we have similar things. That's why I'm saying that in women, some women can tell you that the clitoris erect. They can tell you. All right. So especially those who are sexually active. All right. So that is fine. So the corpora cavernosa, then the corpus spongiosum have semblances. I mean, in the clitoris. Then the foreskin. Remember, we have the foreskin only when you are uncircumcised. There is a structure in the clitoris which is called the clitoral hood. So, and that's where the circumcision is just about removing the foreskin. That's where in some tribes they try to remove, and instead of removing that one, they rather cut off the whole clitoris, which is also very inhumane. All right. The scrotum in males is also homologous with the labia majora in females. You see that the labia majora is the outer puffy structures that you see with the vagina. If you try to close it, you see, if you try to close it, in the scrotum, there's a line. Remember, we talked about the raphe. Okay, there's a line that is trying to separate the two the scrotum. But in the females, that line is open. That will give you an opening to the vagina. But if you try to close it, then you see that it's actually resembling scrotum. Okay. Then we have the bulbourethral glands, which is also called a Capus glands in the males. It has also a similar glands in the females called the Bartholin's glands. All right. So these are some few things that you ought to know as students of andrology. So you see that this is the clitoris, and then of course the penis. There are a lot of semblances. The corpora cavernosa, inside we have the corpora spongiosum, clitoral hold, which is the glands, and so forth and so on. All right, that's just for academic purposes. Now let's look at the functions of the penis. We know a lot of these things already. That primarily is for penetrative population, sex. So, and then for copulation, we are talking about sexual intercourse. And the main essence of it is to for reproduction or procreation. But of course, it's also used for excretion of urine. So this is the dual functionality that we talked about. So that's why we said that the penis is urogenital or genitourinary organ because of the two major functions that it plays. So this is an elaboration of what we are talking about for sexual intercourse, which of course will lead to reproduction, and then also for micturition, which is urination. Other functions of the penis will include sexual pleasure. Some people may just be interested in stimulating their penis just to get it aroused, and then just like that, but they are not even interested in sex. All right, so it provides a source of sexual pleasure. All right, so that also should not be ruled out. Those people who are actually into masturbation, they are not actually interested in sexual intercourse. They are just interested in pleasing themselves, just stimulating their and they're able to reach orgasm. All right, and many of them will actually ejaculate. All right, once that happens, they think that they are satisfied. So that can also be a function of the penis. All right. Any questions so far? So we are done with the penis as much as possible. Any question on the penis so far? Please, are you following the discussion?
Yes, please.
Yes, please.
Okay. All right. And any question?
No question.
Otherwise, we move on. All right. So now, one of the other structures of the external genitalia, we said that when we talk about the male reproductive system, all the structures, some are outside. And one of the major organs that are outside is the penis, which we have done with. And then the other one will be the scrotum. Okay. So the scrotum is the loose patch-like sac of the skin that hangs behind the penis. Of course, it's located between the penis and the anus. All right, that is its location. The scrotum houses the testes.
All right.
Now,
Yeah.
so once it houses the testes, it means that it provides structural support and protection. Okay, this is very, very important. All right. Let me see. There is some information on the chart. Let's see. Okay. All right. So it protects the testicles, and we'll come to the testicles on its own. So for now, we're just describing the scrotum. So it protects protection and support for the testicles. Now it protects the testicles from trauma and other external factors, and also provides a sort of climate control system to help regulate the testicular temperature. We'll talk more on that as we move on. So the testes are enclosed within the scrotum. All right. And as we move along, you see that it plays the major function of the male reproductive system by producing the androgens, which is the testosterone, and also producing sperms. But they are located outside the body. Okay, once they are located outside the body, it means that there must be some kind of protection. Otherwise, anything can just struck it. So the scrotum is providing that kind of protection. Okay. Now, it is also important to note as we move along that the reason why the testis is outside is the fact that the body temperature, which we all know is always around 37, 36, 37, is too high for the proper functioning of the testis. The testis is going to produce sperms, and they're also going to produce hormones. They need lower temperature than the body temperature. And so they are just outside. All of us know that the body temperature outside cannot be the same as the human body temperature. Human body temperature is usually higher than the temperature outside. And even once we come to the outside, and at a certain time, these days, especially in the mornings, the weather is just too cold. Okay, So once too cold, it means that the conditions for the testicles also to perform their function is also going to be hampered. All right, because the temperature for proper functioning of the testicles should be within a certain range, let's say 3 or 4 degrees below the body temperature. But once you have a situation where the temperature has gone too low, then the scrotum is supposed to work in a manner to also bring the testicular temperature a little bit up. All right, we will see how the scrotum does that as we move along. But so the scrotum is protecting the testicles from trauma and also regulating the testicular temperature. How it does that, I'm saying that as we move along, it will come out. As we said earlier, the scrotum is biologically homologous to the labia majora. You know, the labia majora is in females. Okay, and the scrotum is what we're talking about. The scrotum anatomy. So a vertical partition or scrotal septum divides the scrotum into 2 compartments. All right. Each side containing a testicle, epididymis, and the distal part of the spermatic cord. What it means here is that the scrotum is 2, but it's not 2 as in separate 2. Okay, so we have a septum which is trying to divide into, but incomplete. All right, but it's incomplete. So we have 2 compartments, but still, even though it is not 2 separate things, it can still be considered as 2 because each section is able to contain 1 testicle and all the other complements. Okay, right. So it is still regarded as a paired structure. And the division is by what we call scrotal septum. Now, so we said that when we talk about each side, we are talking about 1 testicle, okay, epididymis, and a distal part of the spermatic cord. The spermatic cord is actually hanging that's the cord that's actually hanging the testicles within the scrotum. Okay, all right, we'll see more on that. The scrotal wall consists of several layers, all right, including the skin, dartos, and cremaster muscles, and the tunica vaginalis. These are all muscles within, or that are found within the scrotum, and they all play different roles. Now, the dartos and cremaster muscles control the position of the scrotum and then the testes. So look at the dartos muscles and the cremaster muscles. They play different roles, and their roles complement each other to position the testes within the scrotum. All right. The dartos muscles. Remember, we talked about the dartos muscles and then the cremaster muscles as the major muscles that make up the scrotal wall. Okay. Now, the dartos muscle makes up the subcutaneous smooth muscle layer of the scrotum. Subcutaneous, that is sub means just immediate below. So they lie beneath the skin of the scrotum. So immediately after the scrotum, the skin, immediately after it, the muscle there is the dartos muscles. Okay. And to make it more simple, it is situated immediately underneath the skin of the scrotum. So, and then the cremaster muscles a paired smooth muscle surrounding the spermatic cords of the testes. They work together to regulate the testicular temperature. So you see that the dartus muscles is around the scrotum itself. And then the cremaster muscles is actually the one which is also around the spermatic cord. And it is this spermatic cord which is actually hanging the testes within the scrotum. Please try to follow it, and then you can appreciate the discussion very well. The cremaster muscle descend from the internal oblique muscle of the abdominal wall and cover each testis like muscular net. You see, we will talk about some of the deformities that affect some of the structures of the male reproductive system, and one of it would be cryptorchidism. You appreciate that the testes are developed embryonically, are developed in the abdomen. Okay, so when it's getting to time to deliver, then they travel from the abdomen, pass through the inguinal tissues, and then come out and then lie within the scrotum. As they are coming, they come with a bunch of muscles. Okay, so it is this bunch of muscles which will hold it in place within the scrotum. Okay, and that bunch of muscles plus blood vessels and other things constitute the spermatic cord. Okay, and the major muscle within that one is the cremaster muscle. All right, so the cremaster muscle can contract. Once it contracts, it will push the testicles up. Once it relaxes, muscles will contract or relax. So once it relaxes, it also pushes the testicles further down the body. So that's how it also controls the testicular temperature. So I want you to imagine it. The cremaster muscles is that muscles that is covering the testicles. And this is developed from the abdomen, okay, during the embryonic stage. And then before birth, it is pushed or traveled into the scrotum. Once it's coming with that bunch of muscles from the abdomen. All right. So it is holding it. Muscles have the capacity to contract and relax. So as it contracts, as the muscle contracts, it becomes shorter. All of us know that. Once muscle contract, they become shorter. So once they become shorter, they will pull the testicles closer to the body. So why under what condition would that happen? Once the body is feeling very, very cold, the testicular temperature becomes extremely cold, and therefore the body temperature will be required to warm it up. So the cremaster muscle will contract. Once it contracts, it pushes the testicles up. Once we push the testicle up, it brings it closer to the body. And then the body temperature will also influence the testicular temperature to the level that the testicles will like. If you get to a hot environment, very hot environment, then the cremaster muscles will have to relax. As they relax, they move further, they become longer, and they move the testicles away from the body, so that the body, the testicle doesn't become too hot as the body is hot. So those are some of them. We will talk more about this as we move along. So in this manner, you see that the scrotum is regulating the testicular temperature. What about the dartus muscle? The dartus muscle is actually the muscle that's underlining the skin of the scrotum. you see that sometimes your scrotum becomes very small. Okay, sometimes it becomes also large. Sometimes you see that there are a lot more wrinkles on the scrotum, and sometimes there are less wrinkles. So that is also the function of the dartus muscles. The dartus muscles actually on the skin, and so it also, once it also contracts, it shrinks the what do you call it? It shrinks the scrotum. Once it shrinks the scrotum, it means that the surface area of the scrotum will become less. So it means that it will, and that is in very cold temperatures. In cold temperatures, the scrotum will shrink. The dartus, that one, so you see that the dartus muscle will shrink and then makes the surface area of the scrotum become small. Once the surface area becomes small, it means that the amount of heat that must be released will become reduced. Once it becomes reduced, it is containing or retaining heat. Once retaining heat, it means that the outside temperature is cold, and therefore it needs to warm up the testicles. So meanwhile, at the same time, the cremaster muscles has also pulled up to bring the testicles also closer to the body. So cremaster muscle pulling up to the body, and then the dartus muscle also shrinking. The two processes will cause the testicular temperature to increase. Okay, so that is the actual function of the scrotum, and that's how you're able to regulate the testicular temperature.
Okay, Grandpa.
Yes, sir.
So does that mean that the dartus muscle and then the cremaster muscle work
yes,
hand in hand?
Yes,
Simultaneously.
Somehow, and they also respond to the environmental temperature.
Oh, okay.
You understand?
Yes,
so if in cold temperatures, in fact, here the temperature here is which we describe as cold is not cold. If you travel out, sometimes you think that your scrotum is gone. I mean, if you travel out one day, you want to find out whether your scrotum is gone or something like that. You see, that is the function of the dartus muscles, and then the dartus muscles is actually located within the scrotum itself. That is part of the scrotum. Okay, and then the cremaster muscles is the one that descended from the abdomen. You see, we said that the testicles develop in the abdomen. When it is coming, it is not a free fall. It's coming with, supported by some tissue or muscles. It is this muscle which you keep on holding it within the scrotum, and that forms the spermatic cord. So you have blood vessels, nerves, everything all within the spermatic cord. Okay. These muscles have the capacity to contract. Every muscle have the capacity to contract or relax. So, like I said earlier, if the environmental temperature is very, very cold, very, very cold, then while the cremaster muscle is pulling up or contracting, it is contracting to pull up the testicles closer to the body. That's what it's doing. At the same time, the dartus muscles will also shrink. Once it shrinks, what is happening is that it is reducing the surface area of the scrotum. You know that once the surface area is reduced, amount of heat that will be lost will be reduced. Okay, so that is that. So while this one is reducing amount of blood that will be lost, amount of heat that will be lost, this one is also bringing it closer to the body. So the two of them will work together so that the required temperature required, the temperature required for the effective functioning of the testes, which is producing hormones and also producing sperms, will continue unabated.
Okay.
All right.
Okay. Thank you.
So you get this. Remember that we talked about the RAF yesterday. Okay, this is the line that is coming from the meatus. You know the meatus, that's the urethral opening, running through the penis, through the scrotum, and up to the anus. All right. But here, within the RAF, the muscle which is actually dividing the scrotum is the septum. Okay, so you have the scrotal septum. Okay, so the RAF is just a superficial listing, but within it you have the scrotal septum, which is actually dividing the sac into two compartments, right? So the cremaster muscles, the dartus muscles is with the scrotum itself, the scrotal wall, and then the dartus muscle is the one which is actually holding. So the cremaster muscle is the one which is actually holding the testis within the scrotum. I hope that one is clear. Okay.
Yes, please.
Right. So this an elaborate aspect of it. So this will be the dartus muscles, the cremator muscles now also have blood vessels and also the blood difference also going through it. And the whole entity becomes the spermatic cord. Okay. All right. So that's the anatomy of the scrotum. So now let's look at the functions of the scrotum. And we said again, first and foremost, for protection, is protecting the testis. The testis by nature is supposed to be outside the body because the internal body temperature will not support the effective functioning of the testis. So it must come out. And once it comes out, it shouldn't be naked. So the scrotum is providing that element of protection. All right. So that's the major function of the scrotum. The muscular and thin layers of the scrotum provide a protective barrier for testicles, safeguarding them from external physical damage and injury. Then the one we talked about thermoregulation of the testicles. Thermoregulation is that's regulating the thermometer, the temperature of the testicles, which we call the testicular temperature. Okay, so and we try to explain how the scrotum does that. To some extent, the scrotum also have some used for sexual arousal. If you have a woman by you and is touching your scrotum and it gives you some kind of pleasure. Okay, so it's also a function. It's also important to know that. So the hormonal regulation, we've said again and again that the major function of the testis is to produce sperms and also hormones, of course, the testosterone. All of us know that hormones require strict temperature controls, even in biochemistry, dealing with the enzymes and so forth and so on. Every enzyme has specific temperature at which it performs best. All right. So hormones also require specific temperature, and their production within the testicles will require specific temperature, like we said. So once the scrotum helps the testicles to have the right amount of temperature, the right requirement to create the right requirement of temperature for the production of the hormones. It means to some extent, if you're talking about the functions of the scrotum, you can say that the scrotum also plays a role there. So for hormonal regulation, we're talking about the fact that the scrotum is involved in the production and regulation of the testosterone, even though it is not itself, it is not the scrotum itself which is producing the testosterone, but it is providing the right environment for the testes to do so. And it is important to also talk about it when we are talking about the functions of the scrotum. So that is also about the scrotum. We move to the next thing, which is the testes. This is also another very important area because production of sperms takes place in the testes. And therefore, all the male reproductive system, everything is all centered around the testes. If the testes is not there, you don't have any male reproductive system. Because the male reproductive system is just to produce sperms and testosterone. And this occurs, this is done by the testes. So if you don't have testes, it means that you don't have any male reproductive system working. All right, so testes, I remember I told you yesterday that we can spell it with TES. You can spell it with TIS. If you are talking about TIS, you are talking about one. Remember, testis is a paired organ. Paired, that's two. So if you're talking about one of them and you are spelling is TESTIS. If you are talking about the two at the same time, it's TESTS. So the plural for testis, TIS, is testis, TES. All right. So it's an oval-shaped organ, which is egg-shaped. And all of us know that when something is egg-shaped, it is oval. And oval doesn't necessarily mean round. Okay. At best, you can say it is ellipsoid. So in describing the testis, you can use the words like oval-shaped, egg-shaped, or ellipsoid shape, not just something round, right? It measures about 45 centimeters in length and 2 to 3 centimeters in diameter, and of course, located within the scrotum. Now, the testes are commonly called testicles. Now, though the term testicles strictly refers to both the testes and the epididymis. So I want you to take note. Ordinarily, when we talk about testicles, we are talking about the testis itself and then the epididymis. Now, the epididymis, as you move along, you see that it's also a separate structure, even though it is in close contact with the testis. But it's like, how do I even explain? You can't talk about testis without epididymis, something like that. But in actuality, the testis is different from the epididymis. I hope that point is clear. So once you're talking about the testicle, means that you're talking about both the testis and then the epididymis at the same time. And invariably, when you say testicles, everybody is just talking about testis. And for technicality, I just want you to get that explanation. Even though testis and testicles can be used interchangeably, by the strict interpretation, if you talk about the testis, you are not talking about the epididymis. If you talk about the testicles, you are talking about the epididymis and the testis at the same time. I hope that my point is clear. But loosely, we use them interchangeably. Testicle and testis, we use them interchangeably. And I try to explain them by the strict interpretation. So other casual names for the testicles is the male gonads. Remember, we said that the HPG is the hypothalamus, pituitary, and then the gonadotropins. Gonads, if you talk about gonads, you are talking about the sex organ. The sex organ can be male sex organ or female sex organ. Okay, so in in saying gonads, somebody, which gonad are you talking about? So you can say male gonad. So the adjective must support it. Otherwise, if you say gonads, it can be either the testes or also the ovaries. Okay. Remember, we said that the HPG can be both for males and female. The HPG axis, both the male and female. But if it is for the female, then the gonads now refers to the ovaries. If for male, then the gonads here now also refers to the testes. Okay, right. So you can talk about the testes as male gonads. Of course, people call it the balls. Your balls. When somebody say your balls, or your nas, or your cojones, these are all some jargons that you will come across, and they all refer to the testicles. I think the common ones are the gonads and then the balls, because as we move along, we're going to talk about blue balls. Okay, blue balls technically is not about the testes, it's about the epididymis. Okay, so we do all that, but like I've said, invariably, testes and epididymis have always been put together as the testicles. So anything affecting the epididymis, we tend to think that is about the testes. So blue balls in the strict sense of the word is about the epididymis. We call it the hypertension of the epididymis. We also deal with that another time. But what I'm saying that casually, we refer to the balls as the testes. Like I said earlier, originally the testes begin their development on the posterior abdominal wall, high in the abdominal cavity near the kidneys. That's where testes develop. During the last 2 months before birth or shortly after birth, they descend down the abdomen through the inguinal canal to reach the scrotum. I think I've said this already. Right. So it is important to know that 2 months prior to delivery, the what do you call it? The testis is supposed to travel from the abdomen into the scrotum through the inguinal canal. All right. We say that before or shortly after. So if after birth, the the testes have not descended, which you call undescended testes or cryptorchidism, you give yourself some few months. If it still has not descended, it must be reported as a medical condition. All right. We'll talk about all those things in detail, but this is what you have to know for now. And like I've said already, during the descent, they come along with a bunch of tissues. And that tissues is also made up of vessels and nerves and ducts, which collectively we call the spermatic cord. All right. So that is some good information that you have to know, because we are going to use this information to explain the condition called cryptorchidism. So generally, there are 2 testicles, which we know already, but the process of descent may not perfectly be symmetrical, leading to one testis hanging lower than the other. You see, as scientists, you should know some of these important things, because sometimes somebody will come to you. I look at my testis, like one is hanging and then one is lower and one is upper. You see, the 2 testes are developed in the abdomen, they are descending. They don't descend at the same time. Okay, they don't descend at the same time or at the same speed. So once they descend and fall into the scrotum, the one which comes first will necessarily be weightier, and therefore will cause more weight. And then, so that the one who comes later will get up. So invariably, the left one is known to be usually larger, and then also lies lower. There are a lot of things that people say about it, but They have some people too where the right one is lower than the right, but for most of the time, it's the left one which is lower and it's also larger. So if you have twins and they are being given birth, invariably, they will tell you that the first one that comes out is usually a big boy or a girl, and then the second one is usually smaller, something like that. So if you have the testes developing and they are all descending, they don't descend at the same time. They don't, even if they descend at the same time, by the time they reach their one will outweigh the other. And so it is very common for the testes, one to be lower and one to be higher. So take note. It is also the case that some may even not, as they are descending, some may even be trapped along the way, which I said we'll talk about that one. But we are talking about a situation where they have all fallen or they have all descended into the scrotum. Technically, one will be lower and one will be higher. It is normal. So if you are a scientist or you are a health professional, somebody approaches you, you should know how to die. It is normal. This is normal. And it doesn't create any problem for anybody. But commonly, the left testis is usually larger and suspended more ventrally and situated further caudally. That lies lower than the right testis. This is some small information that you have to know. There is also a repetition that the fact that the testes are suspended on the abdomen by the spermatic cords, which consists of a collection of muscle of fibers, vessels, nerves that run to and from the testes. So I think it is also important to note that the primary organ of the male reproductive system, which is responsible for sperm production, also androgen, which is hormone production. This is the main function of the testis. Okay, so without it, there's no male reproductive system. It is important to know that. So a lot of these things I've said already. The testis, the anatomical position, they are located outside of the body and of course within the scrotum. The cremasteric muscles surrounding the testicles and the spermatic cords helps move the testicles away from and toward the body to maintain ideal temperature for producing sperm. I think I've talked about this already. Although the location of testes outside the abdominal cavity may seem to make them vulnerable to injury, it actually provides temperature about 2 to 3 degrees below the normal body temperature. All these things I've said already, that naturally the testes have been located outside because the main function requires a certain ideal temperature, which should be maintained as much as possible. All right. And the temperature required for sperm production, which we call spermatogenesis, is usually 2 to 3 degrees below the body temperature. All right. And this is very, very, very important. Right. So the internal structure of the testis. Structure, the testis is covered by a tough, inelastic capsule of the tissue called the tunica albuginea. Remember, I said that you should take note of the tunica albuginea. It invaginates or penetrates into the parenchyma of each testicles and form partitions called septa. Remember that you also have a septa in the scrotum. Okay, that's something which tries to divide, but they are unable to divide it completely. Okay, and once you say septa, you are talking about more. So if it's one, it's septum. So with the scrotum, you have scrotal septum, not septa, because you have only one, which is separating the scrotum into two halves. All right. Now, with this testis, we have the tunica aborigina, which pushes itself into the testis. All right. And so once it pushes itself into the testis, it is dividing. All right. Once it is doing, it is dividing. And it keeps on dividing to smaller partitions. So some of these things you may have to imagine it, right? So we said that when we have the scrotum, we had that tissue which tries to divide it. Invagination means moving it inside. Okay. So if you have it only one, it is septum. Now, if you have this one moving in, another one also moving, another one moving in, it means that it is partitioning it. It is pushing it into. So you have several septa and then forming partitions. That's what happens within the testis. So the septa divides the testis incompletely into wedge-shaped, which is pyramid. When it's a wedge-shaped, it's like the base is wide, and then as it moves up, it's like becoming pyramidal. All right, so that's a wedge. Now, and these are called lobes. And then the apex. So when you have a pyramidal sort of thing, the base is wide, and then it's like once you have an orange, okay. If you peel off the covering, you will see a situation of especially I think it's tangerine. There's that branch, that kind of orange called tangerine. If you peel off the covering, you will see that it has been invaginated. It's like you can even pull it off one by one. Okay, once you pull it off one by one, you see that the outside is wider, and then as it moves in, that place narrows. Okay, that is how I want you to imagine it for the testis. That's how I want you to imagine it for the testis. So each portion of the orange that you pull off is a lobule. Okay, it's a lobule, and within the lobules, so if you cut it across, you see that several things also go inside there. So I want you to visualize the testis as if it is an orange. All right, it is an orange where you can pull off the outer covering, and then of course pull off. See, it has been invaginated. Exactly the way the testis is. It has been invaginated, and each portion can be pulled off independently. All right. And so within each of these lobes, there are what we call lobes. You know, a lobe, technically, if you use the word ULE, it is a smaller aspect of what you are talking about. If you are talking about tube, okay, and say tubule, the surface ULE is describing a small aspect of whatever you are talking about. So tube and tubule.
Modules.
All right. Lobe and lobules. Okay. So if you talk about lobule, we are talking about small lobes. All right. Within each lobule, you have 1 to 4 tightly coiled, convoluted tubules. Okay. And this tubule is called seminiferous tubules. It is like, I'm talking about the orange this thing. If you pull it off, you see that there are several things inside. So that small entity inside, okay, is the, how do I even, it's like when you're describing a cell, that is the smallest thing that you can come across when we are dealing with, let's say, a tissue. Okay, so the smallest entity of the lobule is the seminiferous tubules. Is it confusing?
No, please.
Let's.
Okay, all right. A little.
Yes, please.
Okay, so that's where I want you to be. You are all scientists, and you can be. Sometimes you have to be imaginative. All right. I'm saying that take the thesis as if it is an orange, and here I'm talking about a type of orange you call a tangerine.
Tangerine. Okay.
Tangerine. You see that one take a tangerine and you pull it off. You see that you can take off the pieces individually.
Sure.
So that's the lobule. Okay, that's the lobule, and you see that as if something has divided it. So in this way, it is the tunica abugenia, okay, which is the tissue surrounding it, the tissue surrounding the testis, which is trying to do the division. Okay, so it divides it into that wedge-shaped lobule. If you take each lobule out, there seem to be some tubes or tubule which has been coiled within it. I hope that point is not clear.
Yes, please.
Okay, so and that coiled tubes is what we call seminiferous tubules. So it means that if you take off each tube, it's like talking about the kidney and then the nephrons. All right, the nephrons, the individual nephrons make up the entire kidney. All right, you understand? So if you take off the lobe, the individual structures within is the seminiferous tubules. And like we said, because it is a tubule, it means that it's a small tube. So a small tube which has been winding to give you that kind of lobule. I want you to just try to imagine it that way for me. So within each lobule, there are seminiferous tubules, and those seminiferous tubules, they are the single individual structures that make up the entire lobule, and of course that make up together, put up, also become the testis. All right. So you now see that the testis is made out of ducts. You know, a duct is, remember I said that a duct is the same thing like a tube. Do you remember? A duct.
Yes,
a
please.
duct is the same thing as a tube. Okay. Now, so, and you are saying that if you take the lobules, if you take them out, it's a tube that has been wound together. So it means that the whole entirety of the testis is made up of tubes. Do you agree to that?
Yes, please.
Yes. So, and because the tubes are small, very small, you call them tubules. Okay. So you see that the individual structures of the testis is made up of tubules, and these are the seminiferous tubules. And because the tube and is winding, you just imagine if you have a tube and you are winding it, then the tube is winding up and down. There will be a space between one side which is moving up and one side which is coming down. Can you imagine that?
Yes.
You imagine yourself. You have a tube. You try to wind it. If you wind it, you go up and come and down. You see that. Then there's going to be a space between the tube which is going up and the tube which is coming down. So that becomes intertubular.
Oh, okay.
Just try to imagine it. Take any tube at all and try to be winding it up and down. If you are winding a tube up and down, then one side is going up, the other side that's coming down. There's going to be a space between one which goes up and the one which comes down. So that is an intertubular. So you are going to have the tube itself and then the intertubular space. Do you also see that? Are you confused?
No, please.
Good. So there are going to be certain cells within the tube itself and cells also in the intertubular. Do you also agree to that?
Yes,
and
please.
Yes, and the cells in the intertubular play different role. And then the cells within the tubes also play different role. But they are all within the lobule. Remember, we have taken the structure, the tangerine listen that I'm talking about. You take it out, that's the lobe. But within the lobule, there are the tubes. Okay, the tubes are being winding up and down, winding up and down. So you have cells within the tube itself, and then because it's winding up and down, the intertubular. And so the whole structure of the lobule is made up of tubular cells and intertubular cells. Is that also okay?
Yes, please.
If you don't understand some of these things, as you move along to how sperms and then androgens are produced, there's going to be a problem. Remember that whether it's tubular or intertubular, they are still all within the lobule. Whether it is tubular or intertubular, they are still within the lobule. And it is the lobule that make up the testis. So we said that the testis produce the sperms and also produce testosterone. That's what we say bluntly. But if you look at the structure, sperms are produced in one section of the lobule, and then the androgens, the testosterone is also produced for another section. That's why I'm saying that you must appreciate the fact that because the tube and it's being winding, there are certain things within the tube and certain things in the intertubular. All right. So once you appreciate that, you see that within the tubes, that's where the sperms are being produced. And outside the tube, in between, which is the intertubular, is where the androgens are also being produced. But whether it is produced from within or outside, when you are describing, you say that the testes produce sperms and also produce, what do you call it? Also produce androgens. But I'm saying that if you understand where you are coming from, you realize that yes, it is the same testis which is producing, but the site for the production of the sperms is different from the site of production of the androgens. And this is confusing, but you must appreciate it, because once we talk about the gonadotropins, we are going to talk about the pituitary hormones. You see, we talk about the HPG, hypothalamus producing the gonadotropin hormones, gonadotropin releasing hormones to the pituitary. Pituitary is also producing gonadotropin hormones. They will come, these are LH and FSH. But once they come into the testis, they all have different receptors. You know, hormones too will function through receptors. The receptors for LH, the site, is different from the site for the FSH. And so you know that FSH, yeah, they all go into the testis, but FSH go to a different site, and then the LH also go to a different site, because the cells that are responsible for capturing the LH are located within the intertubular space, and then the cells that are also responsible for capturing the FSH are within the tubular. I'm sure this is getting more confusing. I don't know. If otherwise, ask questions, and then, because we need to understand this one to be able to appreciate the formation or production of sperms once we get there.
Sure.
All right. Right. So I want us to move to where there's a picture and then you appreciate this one. So this is the testis, the structure, that structure, right? You see that if this is, look here, this is the tunica abugina. It is this tunica abugina, which is the outer covering of the testis, okay? The outer covering of the testis. And it tries to move into the whole structure, which becomes the septum. It's like you have the picture of the tangerine in mind. The covering of the tangerine tries to move into the whole structure to divide it. All right, so this is the outer covering to tunica abugina, which is trying to move into the whole structure. Once it moves into the structure, this becomes, so here it is more visible here. So here, the outer covering is moving in here, is moving in here, is moving here. So this becomes lobus. This becomes lobus. So, and this becomes one septum, another septum, and that. So this is the septa, which is produced by the tunica abugina. Okay. Now, so once we take one lobule like this one, you see that this is tubes, which is coiled. So as the tubes coils, then they will go up here and then come down. So between this tube and this tube, there is a space here. I hope you're getting it.
Yes.
So this is a tube and this is a tube. Because they're going up here and come down, there is a space here. So this becomes the intertubular space. This space here is inter, because this is a tube, this is a tube. So this becomes the intertubular. All right. Of course, this place is the septum. So over here too, this is the tube, this is the tube, and then this is the intertubular. So the cells within the intertubular space is different from the cells within the tubes. Does it make it clear?
Yes, please.
Good, good. And the work of the cells within the intertubular space is different from the work within the tubes itself. Okay, so within the tubes itself, let's see. This is also another picture. So it's the same thing. This is the covering of the testis and the tunica abugina. And the tunica abugina, which tries to push itself into dividing the testis to create the lobus. So this is a lobule. And if you look at a lobule, you see that it is like a wedge. This place is larger and this place is smaller. Okay, this place is larger, this place is smaller. This place is larger, this place is smaller. Okay, so these tubules will, as they move here, will now also begin to merge. I hope you are getting it. The tubules are here. Once they move here, they begin to merge. They begin to merge. And then they begin to merge also here again. So the merging here is different from the merging here. You see? Here too, you say the same thing. The tubules are coming down, and then here they will merge. The tubule here will merge with this one. The tubule here will also merge with this one. And then here too, they will also be merging to merge again. And then, so this is also the epididymis. All right. But these are the merges. All right. And let's see. So now let's come here. In the apice of the lobus, when we talk about apice, that is the final wedge. Okay, before entering the medial sternum, and the seminiferous tubules become less convoluted and assume a nearly straight course. So this segment of the seminiferous tubules is called the straight seminiferous tubules. Let's look here. I hope you are not sleeping. So this is convoluted. These places are convoluted. But can you see this place being convoluted? This place, is it convoluted?
No, please.
So this is the more convoluted space. But this place looks more straight.
Yes.
So this is called, but this is still part of the seminiferous tubules. So this side becomes straight seminiferous tubules because what happens here is different from what happens here. Okay. what happens within the tubules here is different from what happens here. So here, this is the convoluted tubules, convoluted, I mean, curve. So this is the convoluted seminiferous tubules. Here, getting to this end, they look straight. Here, they look straight. So this place becomes the straight seminiferous tubules, while this place is the convoluted seminiferous tubules. Convoluted seminiferous tubules, and then the straight seminiferous tubules. The straight seminiferous tubules will now also merge again. All the straight seminiferous tubules will merge again to give you what you call the red testis. Okay, it's like anastomosis. When it's anastomosis, we're talking about joining together. You see, we have they do some kind of surgical intervention which they call anastomosis, especially within the GIT. When they have some portion of the GIT, let's say, having serious ulcerations, they will cut here, and then come and join. All right. And so that is anastomosis. Anastomosis is joining two tubes together. All right. So you see that here is a form of anastomosis. This is the rate, so the straight portion of the seminiferous tubules will merge. The straight one from this lobule will merge with the straight one from this lobule, and then they will form the red testis. And what happens within the convoluted area is different from what happens in the straight area, and it's also different from the red testis area, where they are merged together before they also move on. So I want us to understand all this so that when we are talking about the spermatogenesis, that is actual formation of sperms, you can know where it is starting from and where it is ending. All right. So so we talk about the straight seminiferous tubules. Most portion of it is the convoluted seminiferous tubules. We comes to the straight tubules. They are short. You could see it from the picture. Less convoluted and nearly straight ducts in the testicles, connecting the convoluted region of the seminiferous tubules to the red testis. All right. They are a continuation of the convoluted seminiferous tubules. I hope that you can appreciate this one from the discussion that we've had. They anastomose to form the red testis, which is a network of anastomosing tubules. No sperm cells are produced in this portion. Rather, they discharge sperms produced in the convoluted seminiferous tubules into the red testis. I'll go to that again.
Okay, so Doc.
Yes, sir.
So meaning the sperms are rather produced in the convoluted.
Exactly. The sperms,
okay.
all the sperms are produced in the convoluted tubules here. And then they are discharged into the straight seminiferous tubules. Okay. And then from the straight seminiferous tubules, you see that this straight one is from this lobule. This straight one is also from this lobule. So they all come to merge. That's the anastomosis. So once they merge, they form the red testis. So here too, sperms have been formed already. Okay, so from this side, then they'll move into the finally they will come to the head of the epididymis, and then they will be stored here. We'll talk more on this ones once we get into the formation of sperms, but I just want us to have this information that you have to have a look at the structure of the testis and know that yes, the covering of the testis is the tunica abugenia. The testis, the covering tries to push itself within, to like partition the whole structure. So they partition it into what you call the lobules. So this is the partitioning, this is the partitioning, this is the partitioning into lobules. And within each lobule, there are seminiferous tubules, which are convoluted. And it is this convoluted seminiferous tubules that actually produce the sperms. And certain portion of the seminiferous tubules appear to be straight. So they become straight seminiferous tubules, not convoluted. And at this point, sperms are not produced. It is those that are being produced here that are being transported up to this portion. Okay. All right. So the straight seminiferous tubules interconnect to give you the red testes. The red testes also connect again and to form ducts known as the efferent ductus. Okay, efferent ductus or efferent tubules. Efferent means carrying away. Okay, efferent means carrying away. So what it means is that the efferent ductus will carry away the sperms which have been now produced and then bring them to the epididymis proper. We will deal with this one. This is just the structure. But when it comes to formation of sperms, you will deal with them also individually. But you need to get a good understanding of the structure to be able to appreciate the physiology. All right. Okay. So structure, the testis consists of seminiferous tubules. You talked this already, which constitute about 90% of the testicular mass. All right. So if you look here, I mean the entirety, majority of the whole thing is just the seminiferous tubules. So that's why they are saying that about 90% of the mass of the testis is made up of the seminiferous tubules. All right. So the seminiferous tubules are filled with two types of cells. Okay. Now, the germ cells. The germs, all of us know about germ cells. Germ cells are like the pluripotent cell. That's the cell which will begin to produce that's any cell that you want. Okay. So we have within the, we're talking about seminiferous tubules, within the tubes. Okay, we have the germ or spermatogenic. Spermatogenic means those cells that have the capacity to produce sperms. Okay, and then we have Sertoli cells. Sertoli cells is also called sustentacular cell. We'll talk about this. So sustentacular is talking about sustaining. So they are the type of cells that they are able to sustain the germ cells. So within the seminiferous tubules, we have two types of cells. The germ cells, which is the pluripotent or the primary cell, which is going to start off as a sperm cell. All right. And they are being supported by Sertoli cells. One thing that we would like you to remember is Sertoli start from S, seminiferous start from S. So Sertoli cells are within the seminiferous tubules. Okay. Now, as we move along, you see that the FSH, the follicle stimulating hormones, which will also be useful for the Sertoli cells, is also has an S. So as you do that, you understand the word mnemonics. Do you know mnemonics? mnemonics. Mnemonics.
No, please. We don't know, say.
Okay. Mnemonic, but you can know the spelling. Mnemonic, the spelling starts from M, not pneumonia as in P-N-E. Mnemonic is spelled out M-N-E-M-O-N-I-C. Mnemonic. Let me see if I can create a picture of it. I thought I could write something. I'm just trying to see if I can. Mnemonic, M-N-E-M-O.
And I see.
And are you seeing it?
Yes, yeah.
Okay. And this mnemonic, how you spell it? Mnemonic, something as a scientist, you try to develop certain things that will help you to remember. Okay, so mnemonic helps you to remember. You can create your own thing. It can be a song, it can be an abbreviation, it can be anything that will help you to remember something. So like I'm saying, you're talking about sorry. Come on. We're talking about seminiferous tubules, and we're also talking about I will just try to see if I can get my pointer back. So you're talking about seminiferous tubules as the tubes itself, and within the tubes itself, you have germ cells. That one you have to know that they are the cells that will start to produce the sperm cells. So we call them germ cells or spermatogenic cells. And then you have Sertoli cells. So S and S. So if you talk about Sertoli cells, straight away remember that they are within the seminiferous tubules. And then you also remember that I've said that as we move along, we're going to talk about the effect of the hormones, and that is FSH, follicle stimulating hormone. So follicle stimulating hormones will also go into the testes, but their target area is the Sertoli cells. So you say that okay, FSH, because there's an S in the FSH, and there's S here. So it means that FSH will also go into the Sertoli or seminiferous tubules, something to help you to remember. So mnemonic, there are a lot of times you have to develop something to able to remember. As we move along, I think I will give you some of the mnemonics that I developed on my own. All right. So, but like this one, seminiferous tubules, then the Sertoli cells, how to, whether Sertoli cells are within the seminiferous tubules or not. This one will easily help you to get it right. The Sertoli cells are within the seminiferous tubules because of the SS. Good. Right. Then the germ cells, like I said, they are the spermatogenic. They produce the sperms. So they are the cells that will start off to become the sperm cells. All right. So they represent different stages of sperm production, and they are spermatogonia. So there's a variety of various forms of the germ cells within the seminiferous tubules. Okay, within the seminiferous tubules, we have a range of spermatogenic cells. So we have the very the starting point, which we call the spermatogonia. Then they go on to become the primary spermatocytes, and they become spermat. We are going to do all these things in next stages, but I just want you to have an idea for now. So we have the spermatogonic cells or the germ cells located within the seminiferous tubules. And we also within the seminiferous tubules, you also have the Sertoli cells. Okay. So spermatogonia is also plural. Spermatogonium is singular. Okay. So the spermatogonia is the most immature. Remember that we said that the germ cells, we have the early ones, it's like when you're doing hematopoiesis. You know that we have the immature early ones that will progress to become the mature cells. So the immature undifferentiated cell is the spermatogonia. Okay, right. And then as we move along, they will now also mature to become the sperm cells. Let's see how it goes. The seminiferous tubules of the testes are lined by another set of cells called Sertoli cells. So within the tubules, we have the germ cells. And the germ cells could have different forms. And then also you have the Sertoli cells. Now, so let's look at this picture. Let's look at this picture. Now, you see that this is a cross section. Okay, and you know that it's a tubule. A tubule is just a small tube, and then you just imagine it that you have a cross section. You cut it. Once you cut it, if this is the this is the tube. This is the tube, and you have cut it. So within the tube, this is the base of the tube. Okay, the base of the tube, and then this is the lumen. I hope you are following it. Hello. You imagine yourself having a tube, and then you cut it. So when we cut the tube, this is the base of the tube, and this is the lumen. That's the space within the tube. All right. So there are cells that are lining the wall of the tube. So they are the spermatogonia. They are the primary cells, because as they move towards the lumen, they are maturing. As they move towards the lumen, they are maturing. So here, the shape of the cells here is different from the shape of the cells here. It's different from the shape of the cells here. It's different from the shape of the cells here. Before finally they get into the lumen. All right. So as they move towards the lumen, they are maturing. But once they are at the base, they are the immature primary cells, which are the basic germ cells. I hope that point is clear. Then this is a lumen. So this is a tube, the cross section of the tube. This is another tube. So in between the tube, here, this is what we call the interluminal space. Here, interlumen. This is a lumen. This is another lumen. So this becomes the space between. All right, we will deal with all of these things as we move along. All right. So so coming back to this picture too, just trying to have more pictures so that you appreciate what we are saying. So we are having, this will become your septum, and this is, the septum is a division by the tunica abugenia, which is the lining of the testis, the lining. And the lining tries to divide it like the orange, tries to push in. Once they push in like this one, it forms a lumen. Sorry, it forms the lobule. And within the lobule, we have the seminiferous tubules, this ones. The seminiferous tubules, we have the convoluted side and then the straight side. The straight side will merge to give you the red testis, the reti, this one. And then the red testis will also merge again to give you the efferent ductus. I'm saying that the efferent means carrying away. So they are going to carry away what has been produced here to the head of the epididymis. I hope you get that point.
Yes, please.
So it's very, very interesting. It confuses you. So the within the tubules is where you have this one. Within the tubules too, you have the germ cells. And among the germ cells, there are also Sertoli cells. And we are going to explain the function of the Sertoli cells. We have the germ cells, which are the primary immature. So you can have a tube without any cells. That means that person can never ever produce any sperms. You can have a tube, and there are no germ cells. If there are no germ cells, then what are you going to do? Fine, the person can never ever produce sperms. Okay, but you can have the germ cells. You can have all it is, and then produce the sperms, and then into the lumen. And as they move from the lumen, they will move from the lumen of this one and come to the straight tubules. And then if along this side there's a blockage, you see that finally there will be no sperms. But you can do a test to indicate that, oh, the sperms are being produced, but there's a blockage along the line here, which is causing that obstruction. So if there are no sperms, you would simply say that there's azoospermia. But something can happen. You can do a test to confirm that, oh, actually, sperms are being produced. But along the duct, along the carrier pathway, there's a blockage somewhere, and that's what is causing the sperms not being reaching out to where it has to go. All right. So I think it's becoming more complex, but you have to get ready for some of these things. This is beyond the ordinary what do you call it? Reproductive health system, the reproductive system that you normally will learn. So that's why it is usually an advanced program. Okay, even though we said it's basic, but you see that even the basic is not basic as such. Okay, you need to understand some of these things, and then so that as you move to the main seminology, becomes easy to appreciate or to understand. So going back, we are just saying that the testes, the structure of the testes is also very complex. That you have the outer covering of the testes, which you call the tunica abugenia, which try to invaginate. Invagination means pushing into. All right. It tries to, but once it tries to push itself into it, then it means that it's dividing, partitioning it. So you get several partitions. And within each partition, there are tubules. Tubules is a small tube. And they are being coiled. So it become convoluted. When I say convoluted, being coiled. So it become coiled, and then because it is also a long tubule, it is not a straight distance. It's coiled and also like how do I even put it? Apart from being convoluted, it's also it bends of a sort. So once it bends, then in between the bends, there is a space which you call the intertubular space. It's very, very important, because as you move along, you see that within the intertubular space, there's also a set of cells there. And then now you are seeing that within a tubule, the tubule which is convoluted, within a tubule, we have the germ cells. The germ cells are the primary cells, which is going to grow to become the sperms. So we have those germ cells. And you see that germ cells is spermatogenic because that is going to now give you the sperm. So you see that is the developmental stages. So you have it's like when you have a pond and there are tadpoles. You can have some with short tails, some with longer tails, some which is now almost becoming the frog, and some which is just the round. So all those varieties will be seen within the spermatogonial space. I hope that point is clear. So within the seminiferous tubules, there is a group of cells, all of which becomes spermatogenic, all of which will now develop to eventually become the sperm. And it starts with the spermatogonia, which is the primary one, which is the starting point. And now I'm saying that if you don't have the germ cells, then it means that no matter what happens, you can never produce sperms. And the germ cells are, I mean, you are born with it. It's like the woman with ovaries. Okay, the eggs, before you, I'm told that before you can even start anything, there are a number of eggs that you can produce are always there already. So within the seminiferous tubules, the germ cells are already there. And these germ cells are those that are going to now develop to become the sperm cells. Okay. In order not to confuse you more, I think we will end here and continue on Thursday. So please, the thing is basic, but it's not that basic. So get yourself in readiness and let's move forward. Any question, please?
Thank you, Grandpa.
Thank you.
So tomorrow will be off. We come again on Thursday. Now,
Yes,
like I said,
please.
even though we are meeting 3 times, as we move along, if we need to add one extra day, let's say 1 weekend or along the line, I think we all agree and then do that. Otherwise, but for now, let's make it 3 days in a week. As we move along, if you see that we have more ahead of us and we need to add an extra day, we will do that and with your approval.
Thank you, Grandpa.
Thank you, Grandpa.
Okay. But you don't ask questions, or is it that you understand everything?
No, sir.
Uh,
But why are you not asking questions?
Probably, I think when we read through, questions
Okay.
might pop up as we
Okay.
move along.
Okay. Okay. Okay.
Yes, sir.
Okay. So I'll make the slides available to the coordinator and then we'll post them because we don't want the people who have not registered or paid to get access to the same information that you are getting. Otherwise, what will be the need? So there are restrictions on the sharing. Okay. And there are restrictions on the sharing, and that one will be taken care of by the coordinator.
Okay.
Okay, sir.
Thank you.
Grandpa.